Right, morning everyone. Okay, now I'm just going to share my screen with you just to show you some of this some of the things we need to be doing today. All right, okay. So first of all, going back to the lesson that we did on it would have been last week, obviously, where we made the fires. Okay, now I'm going to do the same here. Okay, so I'm going to make a fire. I know lots of people love making fires. Now, so we don't really need to be worried about making any more fires. So here we have, okay, we have created the fire, okay, by putting it's far too many volts for this circuit to take. Yeah, it's not designed for this amount of electricity. Okay, now what I talked about last time is how to avoid those sort of things happening. Let's just bring that back down here again. Let's bring it back down nice and low with the voltage on both batteries, both cells, sorry. And now I'm going to place in a fuse. And actually what you'll find is that every electrical item, pretty much every electrical item that runs on mains electricity anyway, will have a fuse. They'll be in your plugs and they'll be in the in the system of your electricity at home. And what happens is, because sometimes it doesn't happen as much now, but it used to happen a lot more, there would be a power surge in the electricity system, and that power surge would cause too much power to come in into people's houses, and it could be dangerous. But this is what this fuse does, isn't it? What a fuse does in your battery or in your house, it actually just it breaks the circuit. Because if there's too much, if the charge is too great coming through the fuse, it'll pop, it'll break. Okay, and that breaks the circuit. And all you have to do then, because very often we our electrical items break down, and it's actually because the fuse has cut everything out. So we just change that fuse, okay, and then it works again. It would work again. So we would change the fuse. So now, even if we bring this voltage right down, you can see this isn't going to light, is it? It's not going to light. But if we now change the fuse, goodness me, change the fuse to a new fuse, it'll start working again. And then if we have too much electrical charge coming through, the fuse does its job and pops. Okay, and that's why really electricity is so safe in our house, as long as we are sensible with it, of course. Yes, and I know you've been taught about electricity safety and things like that, but actually these without fuses, electricity would be a lot more dangerous. Okay, right, on to more today's lesson. Now, I can remember when I was growing up, okay, every year come Christmas time, my father would go up into the attic. He would bring down let's just put these down to he would bring down the Christmas lights, and the first job to do with the Christmas lights, I'll just put them both on 20 volts. That's quite a lot, but we won't worry about that. The first thing we would do in the Christmas lights is plug them in and see if they worked, and they almost never worked straight away. Okay, so what we had to do is to test every light bulb to see, because one of those light bulbs would break, and then it would break the whole circuit. So we would check every individual light bulb. Okay, and we're going to talk about the different types of circuits today. Okay, let's just bring that out. So what I want to do, never mind. Okay, so now we're going to bring in, so we've got two light bulbs. What did you notice about, first of all, in terms of observation, did you notice anything about the brightness of the bulbs now? Have a little look. Were they a bit dimmer? We'll have, yeah, I'm not too sure. Of course, we can always check that with our voltmeter, can't we, on our meter? Okay, let's break that circuit. So if, for example, we've got this circuit here, if this light bulb here breaks, okay, and by breaking, what it'll do, it'll break the circuit, then the other one doesn't light, and this is what used to happen to our Christmas decorations. Okay, so let's just break this one here. Okay, let's bring another one in. So as you can imagine, we would have in our decorations, in our Christmas decorations, Christmas lights, we could have maybe 50 different bulbs, and we would have to test every single bulb. So, oh, notice again, look at the observation in terms of the brightness of the light, okay? Are they as bright now, or have they gone much dimmer? Now there's 4 of them, okay? Now there's 4 of them, okay? Have a think about that, okay? And actually on the extension today, you can do some work on that and investigate that if you get a chance. It's really interesting. So you can see here again, so we would have 50 lights like this, okay? And then, oh, one of them doesn't work, and then none of them work. So we would go around and we would check, changing every single bulb until eventually you found the one that was causing the problem, okay? Right, so what I would like us to try and I only want you to spend no more than 10 minutes on this. Some of you might be able to do fairly quickly. What I'd like you to do is try and design a circuit that with 4 bulbs like this, but if one of them breaks, or if you break the circuit next to one bulb, the other 3 still work. Because actually that's what happens with your Christmas lights, isn't it? If one bulb doesn't work, it doesn't mean they all don't work. So this is a different type of circuit. This circuit we've got here is called a series circuit, okay? But I want you to try and design a new type of circuit which will allow all of them, which will, even if one doesn't work, it doesn't stop them all from working. So 10 minutes on that, please. This information is also on the portal, okay? So it's challenge number 1 on the portal, okay? Spend no more than 10 minutes, okay? And then we'll have a look at it afterwards. Right, good luck with that. Hang on, let me just go back and stop the recording and see you shortly.